Hello, this is Prof G and welcome back. This is a solution video for question 6 on our 9-question 2.5-hour midterm for physical computing. Feel free to start at the first video if you want to know how I set up the test and my approach to grading in a way that encourages rather than discourages students to conquer tech challenges. The earlier videos also have all the earlier questions and solutions. So with that, let's get at question 6. So question 6 is Goodnight, Wake Up, and we're going to download some sounds from the Light Sounds folder that is at the URL. It's got the resources for this exam. I'll show you how this operates, and then we'll read through a description of how it operates. Light goes out. Things get dark.
Good night, fabulous. You've once again made the world better.
And then things stay quiet and the lights stay off. And then the next day, light goes on.
Time to wake up, amazing one. There's more good to do in the world.
And it'll continue to stay on until the lights go off again.
Good night, fabulous. You've once again made the world better. Time to wake up, amazing one. There's more good to do in the world.
So there you go. You get a little daily affirmation as you go to bed and another one when you wake up in the morning. So we're going to do this in the color amber. What we're going to do here is when the room is bright, has been bright, but now it's dark, we're going to check for a light sensor value. I suggest a value of less than 500. First, we're going to turn on all the lights in the CPB, all in amber. Then we're going to turn them off one at a time from lights 9 down to light 0, waiting 0.2 of a second in between each light going off. So you saw that those go in a nice circular pattern. We're going to put this in a function named lights out, and we're going to call it before we play the sound below, and that sound is going to be the Goodnight wave sound. And we only want to play this once when the room first gets dark and remains dark. So you want to make sure it's not continually going off. That's one of the things you need to pay attention to. There were a few students where their alarms were going off and off and off continuously, as opposed to just playing once when the room got dark and playing wake up when the room got light. So similarly, if the room is dark, but then the sun comes up, light is detected, somebody turns on the light, I suggest checking to see if a light sensor value is greater than 2000. Then we want to turn on all of the lights one at a time, starting from light 0 through light 9, again waiting 0.2 of a second in between lighting each light. We want to put that in a function called lights out, and we want that to be performed before we play the wake up sound. And again, this should only be performed once when the room first gets light and remains light. So you want that to be sort of a light on, light off toggle, and only play once when we first turn light, and then another time when it turns off. So it would be an alarm that would give you a nice message when you shut your lights off at night, and when the sun comes up in the morning, it will give you another nice message. So let's take a look at a solution. So we need digital I/O to work with our speaker, and we need to import these down here to work with the speaker as well. We also need analog I/O. That's necessary for the light sensor, and we're working with NeoPixels as well. Now this is how we set up our speaker. We've done that in the previous exercises. Our path for where the sound files are is going to be light-sound. Always make sure that you've got the slash at the end. And this is how we set up our light sensor. So on the CPB, this is accessed at board.light, and we just call analog I/O analog in. So that's going to set up an input sensor where we can get some analog input. Now we're going to set up our NeoPixel. We've done that before. That's the 10 NeoPixels that are on our board. And I also have a value that I set as daylight equals true. Now let me show you how we're going to use daylight. So down here in our while true loop, I print out the light sensor value just so that we can get a sense of what the value is. Again, you didn't have to do that, but I really do recommend that you print that out. Notice that I printed this inside of a tuple too. So there is an extra set of parentheses in here and a comma after the single value light_sensor.value. That would enable us to print the sensor value out in the plotter if we wanted to, I should say. So it will print it out in the serial console, but also plot things out for us as well. But this is how we use daylight. So we check to see if the light sensor value is greater than 2000, so that means the light came up, and daylight equals false, so that means that it was dark out already. And if that happens, then what we do is we want to show the wake up alarm. So we run our lights up function, we're going to play our wake up sound, and then we turn off all the lights, and then we set daylight to true. And the reason we set daylight to true is we're going to go through this loop again and again. But if we still have light sensor value greater than 2000, and it should be because the lights just came up, we don't want to show our wake up alarm a second time. So that's why we set daylight equals true, and we only do the wake up if daylight was false. So that means, hey, it was dark, and if it was dark but the sensor value says it just turned light, then we go ahead and we do our wake up, and then we set this flag to say, hey, it's now daylight time out. So even though the sensor value is saying, hey, it's bright out, we're not going to go ahead and continue to play this over and over again. Similarly, down here, if the light sensor value falls below 500 and daylight was true, well, that means it was light out, but it just got dark. So then we show the lights out animation. We play the sound good night, and we set daylight to false. Again, the reason we set daylight to false here is because our light sensor is probably going to continue to remain low, and we want to make sure that we don't continue to run this sensor over and over and over again. So if we set daylight to false, we're not going to do that again. And, again, we're going to go back up here if daylight is false. If our sensor value gets bright again in the morning when we wake up, then we know to run the lights up function and to play the wake up sound again. Notice that we also turn the pixels black when we're done with the first sensor value as well. That's important because we just turned all of the lights on and we want to shut them off as soon as we've done our wake up animation and played our wake up sound. We also have a time sleep 0.2 just to give us a little bit of time in between the sensor reading values, so we're not super reading them one after another after another. 2/10 is a fine amount of time to wait. If we look back up here after we defined daylight to true, we defined our color amber and our color black. Now notice we call lights up when the lights go up, so when we have the sensor value above 2000 for the first time in a day. And we also have this function lights out when the sensor value falls below 500. And since daylight equals true, that should be the first time it gets dark at the end of the day. So if we take a look at lights up, well, what we do is we just go through the lights in the range 1 to 9, so we never reach 10. We turn that pixel amber so they all remain lit. And then once we're done with lights up, we're going to play the sound, and then we turn things off with fill pixels fill black. So that's really important so that the lights don't remain on throughout the day. If your lights remained on, they also create so much brightness that you would probably never be able to get light sensor value below 500 again. So it's really important that you shut those lights off, and that was shown in the video on how this is supposed to work. Now if we take a look at how we used lights out, well, what we do here is we run through the function where we go from 9 down to 0. We never reach -1, and we turn them black. So first we turn everything in amber, so we have a bright circle in amber, and then we turn out 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. We never reach -1, and the -1 value steps down by -1. So that's the solution for this. Hopefully you got it. Again, this is the way that we toggled our daylight on or off. There are different ways to do this as well. You also needed to make sure that you did turn the lights off in black, and again, all of this stuff was demonstrated in the video. Hope you did well, and congratulations if you did. And if you didn't, well, now you know how to do this the next time you're confronted with these kinds of challenges. Keep at it.